Today I am going to explain some important topics of chapter Electrostatics. Our first topic is electric flux. Before starting the topics, first of all, I want to tell you that what is electric field lines? Electric field lines are basically the invisible line of forces which are directed from positive charge to the negative charge. As you are seeing in this diagram, that the electric field lines are directed from positive to the negative charges. The topic is electric flux. The number of electric field lines passing through any surface is known as electric flux. Here, in these three diagrams, the electric field lines are passing through the surface. There are three surfaces in which all the electric field lines are passing. So, here in the first diagram, the electric field lines are passing, so these are known as electric flux. In the second diagram, the electric field lines are passing, these are field lines are known as electric flux. But in the third diagram, there is no electric field lines pass through the surface. So, here the electric flux is zero. Now, we are going to find out the flux on the surface of the sphere when a charge is placed in the center of the sphere. Now, in order to find out the total flux on the surface of the sphere, first of all, we will divide the whole surface of the sphere into small patches. We will divide, I am repeating it again, we will divide the whole surface of the sphere into small patches. Let's see, this is the diagram of a single patch. Okay, and since this sphere is enclosing a positive charge, so magnetic field lines are moving from the positive charge to the out of the sphere at every side. Now, let's see the single patch. The patch is so small such that the surface is plane. The surface of each patch is plane. Now, see this patch. If the surface of each patch is plane, then this is the area. The black line shows the black arrow shows the area, direction of the area, while the red arrow shows the direction of the electric field intensity. In this diagram, the two directions are parallel to each other. Therefore, the theta between the intensity and the area is 0 degree. Now, let's find out the flux at this patch. Now, as I have told you that the whole surface is divided into a large number of patches. Now, we are going to find out the flux of each patch. E1 dot delta N1, this is the flux of patch 1, this is the flux of patch 2, this is the flux of patch 3. And if we add all the fluxes of all the patches, then we will get the total flux of the surface. So, total flux of the surface is equal to E1 dot delta A1, E2 dot delta A2, E3 dot delta A3 and En dot delta En. Now, as we have read the formula of the electric intensity, 1 upon 4 pi epsilon naught Q upon R. So, electric intensity depends upon the distance from the charge to a point where we are going to find out the intensity and the magnitude of the charge. If we divide the whole surface of the sphere into small patches, then the intensity remains the same on each patch because the distance remains the same and that distance is equal to the radius of the sphere. So, we know that the intensity of each patch remains the same. The magnitude of the intensity of each patch remains the same. So, we will have E1 is equal to E2 is equal to E3 is equal to E, and which is equal to E, since intensity remains the same on each patch. So we'll write E. Okay, now we can write it as total flux is equal to E delta A1. Now listen. This is E1 dot delta A1. So as I have told you in this diagram, since the intensity and the area are parallel to each other, it means the angle between them is 0 degree. So we will get the maximum flux. So we can write it as E dot delta A1, which is equal to EA1. EA1, because E delta A1 cos 0, and cos 0 is equal to 1. So we can write it as dot, we will remove the dot, we can write it as E delta A1 plus E delta A2 plus E delta A3 plus E delta AN. Now we will take E as common. It will become delta A1 plus delta A2 plus delta A3 plus dot delta AN. And the sum of this area is equal to the total area of the surface. And the total surface area of the sphere, the formula of total surface area of the sphere is 4 pi r square. We know that E is equal to 1 upon 4 pi epsilon naught q upon r, and total surface area of the sphere is equal to 4 pi r square. This 4 pi r square will be cancelled, and the flux is equal to q upon epsilon naught. Now from the formula, we have concluded that the total flux enclosing on the surface of the body, enclosing a charge, does not depend upon the distance from the charge to the surface. The formula shows that the total flux of any body enclosing a charge does not depend upon the distance from the charge to the surface. Or I can say that the total flux of a body enclosing a charge does not depend upon the shape of the body. So this is our conclusion. Thank you very much. Allah.